Hello and welcome back to the Data Unite channel. Today we're going to understand how to implement the Random Forest Classifier machine learning model on a real-world dataset, where we are interested to predict whether a person will open a bank account if the bank targets that person during its marketing campaign. As you can see, I have imported some of the necessary frameworks that are gonna be useful for our exercise, and I have also imported um, uh, the model that I'm gonna use for the video from the sklearn framework. The first thing that we need to do is to load our dataset. So I'm gonna use the pd.read CSV function. And I'm gonna load the first 5 rows. And as you can see, we have 21 columns and 5 rows, but there should be about more than 1,000, 100,000 rows. So let's see the shape. Okay, so we have around 41,000 rows. Okay. Then we should do some, we can start with our pre-processing. So because as you can see, we have many numerical and also categorical features. So for that we can just call the input function, and we can see that we have some that are integer, some that are object, which are normally the categorical features, and some that are float. So we have to address first all of the features, all of the columns that are with type object, because our model, the random forest, does not understand or support string values, because as you can see, we have string values inside of the columns, and we need to change them into numerical values. And for that, I'm gonna split our data frame into 2 data frames, one for numerical and one for categorical features. So num okay. And now I'm gonna load the label encoder data frame, which is useful for encoding our string values into numerical values. And I'm gonna use a label encoder because I will still have only one column for the specific feature, but inside I will have different values for every different for every word that exists inside. So I'm gonna define the label encoder, which is part of the pre-processing framework of sklearn. And I'm gonna apply our label encoder to our cat data frame, which contains all the categorical features. So cat encoders is cat apply. Okay. Now, how can we check if our features have been encoded? We can just read our data frame, and as you can see, we have now we have numbers instead of words or letters. Now we can again concatenate the numerical and the categorical features into one data frame so that we can then continue with our operations to prepare our data frame for our model. So for that, I'm gonna create again the data frame, and I'm gonna use the concat function from pandas, which takes as input the numerical feature, basically the first one, the first data frame, and the second data frame. And then you need to define how you want to concatenate these two data frames. If you don't provide this this value, the data frame will concatenate diagonally. So basically you will have double the rows and also double the columns. Okay, and now if we do data frame.head, we can see that at the start we have all the numerical features, and at the end we have all the categorical features, which are now encoded into numerical again. Because if we do df.info, now you will see that all of them are either integer or float. Now we will define the two data sets, the two data frames, which contain, so the first one will contain all the independent features, and the second one will contain only the feature that we are interested to predict. In our case, our feature that is dependent is the Y feature, because that one contains if a customer opened or did not open a bank account. So we go do the following step, dropping Y, X is 1, and Y will be df.y. Okay. Good. Since this is a random forest classifier, we do not need to standardize our data. We do not need to use standard scaler or to think about the data, or if we have some missing values or outliers, because random forest manages these issues automatically, so we don't have to think about these issues. And with that said, we can continue into splitting our two data frames, X and Y, into training and testing data frames. So at the end we'll have 4 data frames that will be used for the of which 2 will be used to train our model and 2 will be used to test our model. So for that, I'm gonna create first the train and the X test and Y test. Okay, and once I have created these 4 data frames here, I can continue with making my model and training it. So I'm defining the model. And now I'm gonna fit. I'm gonna fit the 2 training datasets, X-train and Y-train. Once this is done, as you can see, I have received this output. This tells me that now our model is ready to be used for a prediction and that it has been trained on that dataset. And for that, we'll create a prediction using as input the X test data frame, and at the end we will compare the Y prediction, the Y pred with Y test in order to see the performance of our model. Okay, so if we want to see the okay, first we'll do the following. We'll see our classification matrix, so basically our classification report, where we put as input the Y tests and the Y pred. Okay, as we can see, we have for the class 0, we have 94% of precision and 97% of recall. And for the class 1, we have 68% of precision and 52% of recall. Or the medium or the weighted average is 0.91 of precision. This is not very good because, as we can see here, we have for the two classes we have a huge difference of with the performance. Basically, this might be due to the two classes to not have the equal amount of records, so we have a skewed data, and in this case we might implement some other ways of for training our model, like for example using a sampling method that will select the equal amount of records for the two classes so that we don't have any bias into our model. Anyway, we can also see the accuracy of our model, so we're gonna do it like this. Okay, so I'm gonna do it like this. 2F. I don't need that. Okay. Okay, so we have 92% accuracy of our model, which is very low, but as I said before, we can implement some sampling methods or cross-validation method that will be take equal samples from both of the classes so that you can train the model into a better environment. Okay, anyway, with this we have implemented the random forest classifier model on a data set, and as you can see, there are many things that we can do and many things that should be done before applying a model to a data set in order to create some predictions or to make some classification predictions and so on. But it's important that you start from somewhere and then you build on it, and also you have to understand what's important for your model, because if you're using some model like decision trees where you are not where outliers, missing values or something similar is not managed automatically by the model, you have to think about it. But if you use let's say like here Random Forest, this algorithm uses can manage these issues by itself, so you do not have to worry about that, but still you can have some skewed data, so you have to think about that, how to implement it and how to resolve it. Anyway, thank you very much for following this video until the end, and see you in the next one. Bye bye.